In this video, I wish to review problem number 4 in the practice document for sections 4.1 through 4.3, and this is the problem of finding angular speed and linear speed. Problem 4 reads, a Ferris wheel has a radius of 35 feet and turns at a rate of 360 degrees. Well, let's just do a quick sketch of our Ferris wheel and see what we can understand about it. So there's the Ferris wheel, and it's 35 feet of radius. And if we put somebody here at the Ferris wheel, and they're going to travel 360 degrees around, and it will take them 30 seconds. Realize that that's one revolution on the Ferris wheel. So the first part of this problem, part A, says find the angular speed in radians per minute. So a method I like to use is to put the units of our solution on the right hand side to begin with, so we know where we're going. So that's radians per minute. And we begin with 360 degrees in 30 seconds. So if we look at this, 360 degrees in 30 seconds, we have to convert seconds to minutes and degrees to radians. Those are two straightforward conversions we've learned in class. So we know that there's 60 seconds in 1 minute. And from this chapter of the book, you've learned to convert degrees to radians. We need radians in the numerator on the right hand side, so we want radians in the numerator on the left hand side, and the conversion factor is pi radians in 180 degrees. And let's just verify we have the correct unit conversions by canceling out the common unit. So seconds cancels that seconds, degrees cancels degrees, and we are left with radians per minute, which is the units we need on the right hand side. And if you do this arithmetic here, you'll find that this is 4 pi radians per minute. Let's move on to part B. In part B, we're asked to find linear speed, and we need to find it in miles per hour. So again, let's use the technique of putting the units we need for our solution on the right hand side. Miles per hour over here. And for this problem, we need linear speed. So if you look at the Ferris wheel, in one revolution, that corresponds to the circumference of the circle. And we know to find the circumference of a circle from your earlier studies, that's 2 pi r. So we have one revolution. Again, we need a distance in the miles in the numerator. And we travel that one revolution, and it took us 30 seconds. Because the original given information is we traveled 360 degrees in 30 seconds. 360 degrees corresponds to one revolution. We know in one revolution we travel the circumference, so that would be 2 pi, and r in this case is 35 feet, and that's one revolution. So now we have, I'm just going to show you that by canceling out the revolutions, we have a distance per unit time. It just turns out on the left hand side at the moment we have feet per second. We have to convert feet per second to miles per hour, and that's pretty straightforward because 1 mile is 5,280 feet, And if you didn't remember that, that's something you could look up online, or you could ask me in class if you were taking an assessment. I would have no issue giving you that conversion factor. And we can convert seconds to hours. This 3,600 seconds in an hour. Again, I like to double check that I've made the correct unit conversions here. So again, let's cancel. And I forgot to put the feet marker there. So we have seconds, cancel seconds, feet, cancels feet, and now we have hours in the denominator and miles in the unit and the numerator as the only units remaining. If you do all these computations, you will find this is approximately 5 miles per hour. That will conclude our video.